Yeah, I kind of like this microphone.
Oh, dang it. Oh,
I
really?
don't have to raise my voice. All right, today's lesson is physics, pretty much. So, we discussed this before. If you are given the graph of time versus position, then what does the slope of the tangent line tell you? The instantaneous velocity. But isn't derivative same thing as slope? Yeah. So, if you are given the graph of position, like this, then the derivative is simply the instantaneous velocity. The derivative of position is instantaneous velocity. But that makes sense, right? That's what you guys learned in physics last year. And if you are given the graph of velocity versus time, then what does the slope of the tangent line tell you? The instantaneous acceleration. So the second derivative of position, or the first derivative of velocity, is the acceleration. Okay, so what I'm going to do is I'm going to give you a problem like number 1 on tonight's homework, and we'll go through everything you need to know. This is exactly what you got to know on the AP exam. Wait a minute, I can't even remember if I pressed the play button on the video. I hope I did. I think it is. If not, too bad. Okay, so let's say we have a particle moving on the x-axis. See, now on the AP exam, sometimes they tell you the particle is moving on the x-axis. Sometimes they tell you the particle is moving on the y-axis. Sometimes they tell you it's moving on some other line, like a y=2 or x=5 or something. Okay? But let's just say the particle is moving on the x-axis, and the position is given by, let me just make up something. Something like this. This is the position equation. Okay, so the first thing we want to do is compute the instantaneous velocity and acceleration. So, if this is the position, to get the instantaneous velocity, you just have to take the derivative. Now, do I want to take the derivative like this, use the product rule, or should I multiply it out? What do you think? What's going to be easier? I think in this case, multiplying out is better, because it's easy to multiply out, right? So this is 3 times t squared minus 4t plus 3. Distributize the 3. And you get t squared minus 12t plus 9. Now it's easy to take the derivative, right? Because you just have 3 terms. So the instantaneous velocity, I'm just going to call it the velocity from now, is, take the derivative, so easy. Really? 6t Wait, oh yes, wait a minute, time out. This is not the problem I wanted. Okay, start all over. I wanted this to be the velocity. Okay, here, you know what? Shh. Don't look. Don't look. I said don't look. I see you looking. Gosh, I can't believe I did that. Give me a number, 7. Okay, here. Here is the position. That's what happens when you get old. Okay, here is the position. Now I was going, what's going on? That's not the problem I wanted. No, this is the problem I wanted. Okay, take the derivative, which is the instantaneous velocity. Now 3t squared minus 12t plus 9. Okay, now it's going good. Okay, so what you're going to have to do tonight is you're going to have to make number lines for the velocity and acceleration. Remember I had told you we're going to come to a point where you're going to make number lines on almost every problem? Well, we're here. Okay, so, and of course, on tonight's homework, do you have to use your calculator to find the derivative? Oh, not yet. Okay, so, how am I going to make the number line for this? You need to have it all factored, yeah? So you take out a 3. This is what I wanted. T minus 1, t minus 3. See, easy to make a number line for that, yeah. Now, whenever you make a number line on the AP exam, it must be labeled. Otherwise, it's not gonna count as part of your work. So this is a number line for the velocity. What numbers do I put on this number line? 1 and 3. And then, come on, either think of the graph, parabola opening up, or plug in numbers, plug in like a number bigger than 3, like 4. Positive times positive times positive is positive. Think of a number in between here, like 2. Plug it in. Positive times negative is negative, because a positive times a negative equals a negative. Say it. A positive. Never mind. Anyway, just think of the graph. It's a parabola opening upwards, above, below, above. Question.
On the x-axis, could you write just the derivative of x instead of v, or do you have?
No, this is not a number line for the x-axis. This is a number line for the velocity.
Or, sorry, derivative of the position.
Oh, you mean just write x prime?
Yeah.
Yeah, you can.
Alright.
Okay, but I'm not gonna. Okay, now we're gonna do acceleration. Now, if this is the instantaneous velocity, what is the acceleration? You take the derivative of that. What's the derivative of this? 6t minus 12 plus 0. Easy. Can I make a number line for this? You bet your bippy you can. Factor out a 6. Okay, label it. Or you can put x double prime or v prime, I guess, if you want. And then 2. And then, what do you think? Is it going to be plus minus or minus plus? What do you mean minus plus like that? Because it's aligned with a positive slope, right? Or how about just plug in a number, right? Like plug in 0 here, plug in 3 there or something. Okay, now once you do all this, you can answer all the questions. Okay, so here we go. What is the initial position? In other words, what is the position at the very beginning? And when is the very beginning? When t equals 0. There's no such thing as negative time, right? Well, in this class, there's no such thing as negative time. So, what is the initial position? That's x of 0. That means plug in 0 into the position equation. You just got to know which equation to work with. Come on, can you guys plug in 0? Negative 7. What is the initial velocity? That means v of 0. What is the velocity at the very beginning? 9. I think everybody here can plug in 0. You just got to plug it into the right equation. What is the initial acceleration? In other words, a of 0. Here's the acceleration. Negative 12. Okay, that's easy. When is the particle at rest? That's something from physics, right? At rest. Well, what does at rest mean? That means it's not moving at all. And if the particle is not moving at all, its velocity is 0. So here's the velocity. What will make this 0? 1 and 3. So at t equal 1 and t equal 3, that's when the particle is at rest. When is the particle moving to the right? Come on, you guys just took physics last year, right? When the velocity is positive, right? When the velocity is positive, it's moving in the positive direction. That means to the right on the x-axis, right? If the velocity is negative, it's moving in the negative direction. That means to the left. But if it was moving on the y-axis, positive velocity means it's moving up. Negative means it's moving down. So it's all relative, right? So all you gotta do is look at your number line. When is the particle moving to the right? In other words, when is the velocity positive? Just look at your number line. So what do you write? 0 to 1, and then 3 to infinity and beyond. Wait, Mr. Park, how come it includes 0? No, let me ask you that. Why does it include 0? Because here's 0. Isn't the velocity positive? Yes. Therefore, it's moving to the right. That's why it includes 0. Okay, now when is the particle moving to the left? particle, that would be when the velocity is negative. Just look at your number line. When is the velocity negative? Really? Between 1 and 3. Of course, this is a simpler example. You might have to like use synthetic division to factor it or whatever. But that's the key to everything. You factor it and then you make a number line. Okay, when is the particle speeding up? Now, another way to say speeding up, they do this interchangeably on the AP exam. Sometimes they say speeding up, but sometimes they ask, when is the speed increasing? So you have to know that they both mean the same thing. Speeding up and the speed increasing mean the same thing. So, come on, somebody, impress me from physics. How do you tell if a particle is speeding up? You have to look at both the velocity and the acceleration. Every year, even though we go over this, they only look at the acceleration. No, you have to look at both. Okay, let me just tell you. A particle is speeding up when the velocity and acceleration have the same sign, either both positive or both negative. All you gotta do is look at the number line. See, this is why I stack the number lines one on top of the other so you can see. So look at these two number lines. Where do they have the same sign? Between 1 and 2, they're both negative. And then where else? From 3 to infinity and beyond. Everybody, do you guys remember that from physics, or do you guys just memorize stuff and it's all purged now? Mr. Parker never even learned it. Well, does this make sense though? Because think about it. If the velocity is positive and the acceleration is positive, that means it's moving to the right. And then that means if the acceleration is positive, that means, right, the velocity is getting bigger, right? Question.
Wait, how come it's not 2 to infinity, just the 2?
Because from 2 to 3, see, from 2 to 3,
Oh.
this is positive, but over there is negative, yeah?
Oh, okay.
So, yeah, we're only looking for where they are the same sign, yeah? And then, when is the particle slowing down? And of course, another way to say this would be, when is the speed decreasing? Okay, so from physics, when is a particle slowing down? When the velocity and acceleration have opposite signs. Okay, so that's why, stack the number lines and it's easy. Now look at these two number lines. Where do they have opposite signs? Come on, my dog can do this. From 0 to 1. How come we include 0? Well, we already talked about that, right? Because at 0, the velocity is positive and the acceleration is negative, so therefore it's slowing down, right? And then where else? Where do they have opposite signs? From 2 to 3. There you go. And then at t equals 0, okay, why don't we just do this then? Okay, now let's do, okay, let's do it that way. At t equals 0, is the particle, we like to ask this question on the AP exam as well, is the particle moving toward or away from the origin? And then you gotta explain why. Explain, that's not how you spell explain, fool. Explain. So, just think about it. What do you have to know to figure out if the particle is moving toward or away from the origin? Okay, let me tell you. You gotta know the position, and then you gotta know the velocity. You don't need the acceleration. So, what is the position at 0? We actually already computed that already. If you look way up there, it's -7. That means it's to the left of the origin, right? Isn't -7 to the left of 0? Okay, and then what is the velocity at 0? We already computed that up there, it's 9. Oh, it's positive. that means the particle is moving to the right. So think about it. Draw a picture if you have to. Here's 0, here's -7. The velocity is positive, so that means it's moving to the right. So what do you think? Is it moving away or toward the origin? Toward. So the answer is toward. I gotta fit this in here. Toward, because, okay, you kind of know by now how to explain your answer for the AP exam. Well, what do you say? Because the position at 0 is negative and the velocity at 0 is positive. And of course, you want to show your computations to get that, yeah? And that's it. We answered all the questions. I tried to think of all the questions they ask on the AP exam and I put it on this worksheet. See, that's the thing with your book. Your book teaches you some things, but it doesn't teach you what you have to write down to get points on the AP exam. But since I correct AP exams for many, many years now, in fact, all our teachers, Iolani is one of the few schools in the nation where almost all of our teachers actually correct the AP exam, so we know exactly what you have to say. Yeah, and I'm not going to tell you how to do J because you guys should know how to solve any equation on your calculator. Okay, so now that we did all this, let me give you one problem that'll show up on the multiple choice here. Let me think. Time versus velocity. Give me a graph. Okay, right here. Here is 2. At t equal 2 is the speed increasing. Well, I don't know. This maybe this would be a free response question, or decreasing. Explain. How do you tell if the speed is increasing or decreasing? Now remember, that's the same thing as asking is the particle speeding up or slowing down. So what do you have to know for that? We just learned it. You gotta know the velocity and the acceleration. You have to know the sign, right? If they're the same sign, the speed is increasing. Opposite sign, the speed is decreasing. So here's t equal 2 right here. What can you say about the velocity if this is the graph of velocity? It's positive because it's above the x-axis, right? If the y-coordinate is up there, it's positive. So v of 2 is positive. You don't know the exact value, but you can see that it's above the x-axis, so it's positive. And what about the acceleration? Well, isn't acceleration the derivative of velocity or the slope? So if this is the graph of velocity, wouldn't the slope be the acceleration? Okay, so what can you say about that slope? Is that a positive slope or a negative slope? Negative, because it's going downhill. So if the velocity and acceleration at t equal 2 have opposite signs, what? The speed is decreasing. So you would say the speed is decreasing because v of 2 and a of 2 have opposite signs. That's how you get points on the AP exam. What would happen if they both were the same sign? Then you would say the speed is increasing because v of 2 and a of 2 have the same sign. Question?
If we're not allowed to abbreviate, can we still write v/c?
Oh yeah. That's because that's why, right? They don't want you to abbreviate like IVT, intermediate value theorem, because they want you to actually know the name of the theorem. Because next chapter, we're going to, in addition to the IVT, intermediate value theorem, we're going to learn the mean value theorem and the extreme value theorem. So yeah, and then fundamental theorem of calculus. Some teachers like to write FTC, but you can't do that on the AP exam. Questions?
I'm just wondering why they make it so complicated. Like, couldn't you just say that like v is approaching?
Yeah, you can. You can. You can explain it lots of different ways, but if you just listen to what I tell you, that's the fastest way to do it. Because you'd be surprised, because the people who don't correct, teachers that don't correct AP exams, they don't really know what you have to write, so they just tell their kids to write a paragraph. But since we correct the AP exam, you just need like a sentence. Isn't that a lot better?
Yeah.
So as long as you write the right sentence, you get the points. Why is it time to leave already? Yeah, pretty much. Okay. So one more lesson for this chapter. We're going to take the derivative of the trig functions tomorrow. And that's it. That's the end of the chapter. All right. I will see you tomorrow. Yeah, I like this one. I'm gonna keep using it.
Thank you, tomorrow.
Good. See you tomorrow.